Hey guys, welcome to AlgoYogi and let's solve evaluate Boolean binary tree. So let's go to the problem. We have already solved this. So basically the description is quite really simple. It's too much, but it's very simple. I'm sure you guys have been through it, but let's read it. You are given the root of a full binary tree. You can skip if you don't want to hear this. Just skip it to the solution. You're given the root of a binary full tree, and full tree means you already know from the definitions it has to be complete. So you're given the root of a full binary tree with the following properties. Leaf nodes will have either 0 or 1, where 0 represents false, 1 represents true, and non-leaf node is 2 and 3, and 2 represents basically or, and 3 represents and we need to basically evaluate the entire tree. So even in the algorithm, it's if we have a very long Boolean expression that we need to evaluate based on some conditions, it will be basically evaluated in the tree format as well. So we're simply asked to evaluate the entire value, either true or false, Boolean value of this binary full tree. So to basically understand how we're going to do it, let's see it on our iPad. So the non-leaf nodes will be either or and. So here we can see, so when we are evaluating basically this tree, then from left it's getting true, and from right it has to process this AND, which has false and true. So AND false true AND operation, which basically false, and when it returns false from here and true from here, this is getting true or false, then it's returning true. And that's what our answer here is, right? Now the way it's doing it, first evaluating this, appending it over here, and then it's showing it in this way. So I guess the problem is really simple. It's just we know how we're going to trade. The only trick here is when you are basically evaluating the expression, you only want to evaluate the leaf nodes, and if it is 0, return false. If it is 1, return true. And otherwise we are just based on if it is 2 or 3, we are either using the or using the or operation or and operation, and if it is 2 or if it is 3, and operation. So let's go back to our coding ground, coding gym we call it. So simple, really simple. So what are we going to do? If root is none, that means what? We return true. We didn't have to do anything. If it is a leaf node, how do we check if it is a leaf node? If this root's left is none, if this is none and root dot right is also none, that means we return true if root dot well, if it is a leaf, it's going to be either a 1 or 0. So if it is root dot value is 1, we are returning true, else we return false. Awesome. If what? Else if our root value is 2. If it is 2, what does it mean? It means it's a 2 represents Boolean OR operation. Okay, OR operation. So if it is 2, then what do we return? We return self dot evaluate. It's too lazy to type here. We evaluate root dot left, and what do we put in between? OR. And that's what we want to return. or right. Otherwise, finally, let's return else. We don't even need to check if it is equal to 3. We can just simply on the left, I mean, yes, this. Now it's a or and condition. This is it. Let's try to run it. Let's try to run it, mate. Yeah. Yo. That is good. That is good. Okay, we're submitting it. Awesome. We are done. Let's write the time complexity. Same old, buddy. Same old. Big O fan. We just use. That's the number of nodes we're visiting. Yeah. It's about visiting every node and not really what we are actually using here. But anyway, space complexity would be big of h this time, because it's a full tree. Then we don't really expect it to be having this left. We don't want that. That is not in the definition of a full tree. So it would be a proper height this time. Okay, you can say that. You can mention that in your interview. Okay, let's go back to our AlgoYogi and mark it true. And see you in the next problem. Bye bye.